Welcome to Happy Class Online School. This Mathematics Grade 5, the first term and group 2, and this is part 6 of the course. So we are still in fraction, and today we are talking about how to convert from decimals to fractions. So before you actually start listening, I want you to prepare yourself. So the first thing is that you get your notebook ready, and make sure you get your pen and pencil ready, and along with a cup of water closer to you in case you are thirsty, so that you won't just be standing up from the in front of the phone or whatever you are watching the video with. So get your water and pencil, pen, get everything ready. So but make sure not to take your take the cup of water closer to you so that you won't pour it on your book. So and then make sure you sit on a comfortable table like this one you are seeing here. If you don't have that one, you can just find somewhere some place to sit where you are comfortable, and then stay in a silent place where no one will disturb you. And then just make sure you don't when you put on the earphone, or if you are not using the earphone, make sure that you don't loud the earphone too much so that it not damage your hearing. So the most important part, the most important part in changing decimal to fraction is reducing the fraction to lowest term. If you don't understand what lowest term is, don't worry, I'm going to explain everything to you. And the process of changing decimals to fraction is hard, and the only part that is hard there is reducing fraction. So let's us first learn that. And so the first thing is to reduce fraction to lowest term is to understand that we have two methods in reducing fractions. You understand? If you want to reduce fraction to lowest term, we can actually use two methods. So the first method is the prime factors method, and the second method is the dividing. So dividing means what number goes in something. So the first one, which is the prime factor method, you must know how to find prime factors of a number. So before you be able to reduce fraction with the prime factors method. And it is not important to know divisibility rules. If you don't know what divisibility rules means, that now, don't worry about it. We'll talk about it in depth, and you'll be able to understand better what divisibility rules means and how you can use it to reduce fraction to lowest term. It's the most common one, and you probably see how it is being done the easiest way, and how you can actually quickly reduce fraction to lowest term, so that you will be spending years or days in working in with a fraction question. So how to find the prime factor of a number? The first thing you need to understand is that a prime factor is of a number a set of prime numbers. Before you can see that I underline prime number here. So in case if you don't know what prime number is, I'm going to explain that to you, and I will tell you all prime numbers from 1 to 100. You understand? So prime factors of a number are the set of prime numbers including repeats. You understand? So that when you multiply them together, you get the number. So for example, now we have 12. So the prime factors of 12 is 2 times 2 times 2 times 3. That means 2 times 2 is 4, and 4 times 3 is 12. You can see that we have 2 times. Then we have we have a prime number that's repeat. We have 2 times there. And if you multiply 2 times 2, you get 4, and 4 times 3, you get 12. That means 2 times 2 times 4, 2 times 2 times 3 will equals to 12. And the same with 10. And the same thing with 10, we have 2 times 5, which equals to 10. So to understand this better, let's review the two types of natural numbers. So if you don't know what the meaning of natural number is, so natural number is, if you want to understand what prime number is, you understand, let's understand what natural number. A natural number is just counting numbers from number 1 to whichever way you stop, you understand, to trillion, million, and others. So, and then keep this in mind that 1 is neither prime number not a composite. You are going to, in the next slide, I will show you what a prime number is and what a composite number is. In fact, after explaining it to you, when you just see a number, you'll be able to declare that whether the number is prime number or the number is a composite number. So natural number, now we have two. We have the prime numbers, and prime number is also called prime. And we have the second one, which is the composite number. So the prime number, so a prime number is divisible by exactly 2 positive numbers. So exactly by 2 positive whole numbers, and those 2 positive whole numbers are 1 and the number itself. So a composite number is divisible by at least 3 numbers. So it's not divisible by only 2 numbers, but a composite number is divisible by at least three numbers. So examples of prime number is 2, 3, 5. If you see 2 now, so there's nothing can goes in there's only 2 numbers that goes in 2, and that is 1 and that 2 itself. And we have 3, 5 and so on. So for composite number we have 4, 6, 8, 10 and so on. So this table here, you understand, we have from number 1 to 100 here. So I will explain to you what the prime numbers are from number 1 to 100. So the one that that is dark there, you understand, that's 11, 2, 3, 5, 7, 11, 13, 17, 19, 23 and others that are deep there, you understand. So they are the prime number. And the second order is like 4, 6, 8, 9, 10, 12, 14, 15, 16. They are the composite number. That means 100 also is a composite number. And you can see there that 97 is also a prime number. And 83 is a prime number. So 84 is a composite number. So, and you usually find the prime factors of a remember that I explained to you that we can reduce a fraction using a prime factors method. So we are still in the prime factor method, and don't worry, you'll be able to understand it better. But if you want to find the prime factors of a number, we usually find the prime factor of a composite number, because since prime number have only 2 factors, it has just only one. It's just 1 and the number. That means the prime number of 7 is 1 and 7. You understand? So 1 times 7, that is 7. Now factorization tree now. So before you understand how to actually use prime factorization method to find to reduce fraction, let's see how you can find the prime factor of a number. So for example, now if you ask to find the prime factors of 8, the first thing that you write is like this, and you ask yourself that what can you multiply together can give you 8? You understand? A whole number you can multiply together can give you 8, not a decimal one. You understand? So we have 2 times 4 now. So 2 times 4 is 8. That 2 times 4, you split it into 2, and you write it like you write the 2 here and you write the 4 here. You understand? So and then circle 2, because 2 is a prime number. Remember what the table I showed you there, that 2 is also a prime number. That means you circle the prime number. And 4 is a composite number. That means you have to split 4 into 2 again. You have to split 4. You understand? That means we have 2 times 2, which is 4. And we can now do it like this. Because both 2 are prime numbers, so we circle them. So we now have that the prime factors of 8 is 2 times 2 times 2. You understand? So 2 times 2, 4, 4 times 2, 8. If you multiply this 2 times 2 times 2, 2 times 2 times 2, now you get it. That means these are the prime factors of 8. Now that you understand that, let's quickly see how you can how to reduce fractions using the prime factorization method. So example now, let's reduce 4 over 10 to the lowest term. So the first step we need to do is to find the prime factors of 4, and we are also going to find the prime factor of 8. Don't worry with this one, we are going to jump right to the board and I will show you everything. I'm just explaining here. Don't worry if you are not clear with the explanation. We are going to go to the board and we'll jump right to the board and I will explain everything to you in detail. So don't worry if you don't understand it. You understand? So the first thing is first step is that we are going to find the prime factors of 4 and 10. And the second step is that we are going to cross out any common factors or any common number in the numerator and the denominator, and we are going to multiply the remaining. So let's jump right to the board and let's see how it works. So now welcome to the board, and here I'm using color green. You can see that. And so I said we are going to reduce 4 over 10 to the lowest term using the prime factorization method. You understand? So, and I said the first thing we are going to do, and I said the first thing we are going to do, why am I writing 0 like this? So, and I said the first thing we are going to do is to find the prime number of 4. Now, let me quickly do it here now. So, if you want to find the prime factor of 4, we are going to write 4 like this, and we are going to split 4 into 2 or 1 into 3. What can you multiply together that will give you 4? So we have 2 times 4 now. So we have 2 times 2, and since 2 and 2 is a prime number, we are going to circle them You understand? So the prime factors of 4 now is 2 times 2. So that's the prime factors of 4. And what of the prime factor of 10? So what can you multiply together that will give you 10? We have 2 times 5. You understand? So because 2 is a prime number, we are going to circle it, and 5 is a prime number, we are going to circle it. That means the prime factors of 10 is 2 times 5. You understand? So we are now coming back to this now, because we want to reduce this to the lowest term. We want to reduce 4 over 10 to the lowest term using the prime factorization method. So what we are going to do now is write equals to here. So we have 4 here, that means 4 will be 2 times 2. So we are writing the prime factors there, and 10 will be 2 times 5. So remember what I explained that the other time, that the second step after you write the prime the second step after you write their prime factors is to cross out the common numbers or the common factors in the numerator and denominator. Now we have to, now 2 here is common now, so we use 2 to cancel this one. So what will remain here is 1, and what remain here is 1. So we now have 1 times 2 over 1 times 5. So, and you can easily know that 1 times 2 is 2 and 1 times 5 is 5. So that means when you have to reduce 4 over 10, you can easily use this method, and your answer will be 2 over 5. So that's the example for the first one. So let me give you one more example here. So the second example I'll give you now is the is 8 over 9. So let's reduce 8 over 9 to the lowest term. So if you want to reduce 8 over 9 now, we know the prime number of 8 to be 2 times 2 times 2. You understand? So 2 times 2, 4, 4 times 2, 8. And the prime factors of 9. Now what can I multiply that will give you 9? So we have 3 times 3. That means 3 times 3 is the prime number of prime factors of 9. So you can easily see now that there's nothing in the numerator here and there's nothing in the numerator. That means you just multiply it, because there's nothing you can cross out. That means 8 over 9, if you can now reduce 8 over 9 to lowest term. So 8 over 9 is already in the lowest term. So this will be your answer. So that will be your answer. So 8 over 9 is still 8 over 9. So the reason why I'm showing you this is that there are some times when you will reduce fraction like this, and you will find out that their numerator and their denominator is just, there's nothing you can cross out in here, and so don't panic if you see that kind of question. Just know that since there's nothing you can cancel out from the numerator and denominator, so the fraction is still the same as the number, as the fraction term you start with here. So this is the lowest term. So let me do another example for you, because I want you to understand this better. So let's say you want to reduce 10 over 12. You understand? 10 over 12 to, I mean, you can do this. You can pause the video and do this for me now, because we want to be quick with this. So pause the video and reduce 10 over 12 to the lowest term. So if you do that one, and you just watch my own answer. So the prime number of 10 is, we have already done that one before, so don't let us waste time here. So that will be 2 times 5. You understand? So that is 2 times 5. And the prime factor of 12 is, let's find it here. So what can I multiply together that will give you 12? We have 2 times 6. And you know 2 is a prime number, so we are going to circle it. So prime 6 is a composite number. That means we are going to still split it. What can I multiply together that will give you 6? That's 2 times 3. You understand? So 2 times 3. So because 2 is a prime number and 3 is also a prime number, you can say the prime number of 12 now will be, so this is an equals to, so that will be 2 times 2 times 3. So 2 times 2, 4, 4 times 3, 12. That will be 2 times 2 times 3. Now we can easily know that there's some words there's a number in the numerator and the numerator that are the same. So we have 2 that is the same here. We cancel out 2. So this is 1, 2 here, 1, 2 here, 1. What remain here is 1 times 5, you understand, and 1 times 2 times 3, and 1 times 5 is 5 already, you understand that one. And then 2 times 1 times 2 is 2, 2 times 3 is 6, you understand. So we have 2 times 3, that's 6. So we have 5 over 6. That means 10 over 12 to reduce to lowest term is 2 over 6. So if that one is clear to you, let me quickly do this one. Do this exercise too, because I want you to understand this so that you won't have a problem when you are reducing fraction. And this will be the last one. I promise that. So let me change this one to green. So we have 7. We have to reduce 7 over 14 now to lowest term. So we want to reduce 7 over 14 to lowest. Let's assume that you are changing decimal to fraction and you end up getting this kind of thing, and you want to reduce to the lowest term. So what you can do is that find the prime factor of 7, and the prime factor of 7, if you remember that 7 is a prime number itself. So the prime factor of 7 will be 1 times 7, you understand? And the prime factors of 14 will be, now let's reduce it. What can I multiply together give you 14? That's 2 times 7, you understand? So that's 2 times 7. So 7 is the prime number of circle, 2 is the prime number of circle, and that means the prime factors of 14 will be 2 times 7. So this 2 times 7 now is what we write here. You will now write 2 times 7. Now what is common denominator and common denominator? You can easily see that it's 7. So we are going to cancel 7. 7 here 1 and 7 here 1. So what remains here is that we have 1 times 1 and we have 2 times 1. Now 1 times 1 is 1 and 2 times 1 is 2. That means 1 over 7 over 14 reduced to the lowest term will get 1 over 2. So quickly rewind back to the video and make sure you cross check everything so that you'll be able to know how to reduce. Now I think I've done my part. I've explained to you how to reduce fractions using the prime factorization method. So there's nothing hard there. The first step is to write the prime factors of the numbers of the two, denominator and numerator, and you can cross out the one that's the same from the numerator and numerator, and after that one you can just multiply it, you remember. So if you're not clear with this one, just go back and make sure you do all the exercise. So you can go back, you can write this 7 over 14 out and do it yourself, and just make sure you cross check whether you get the answer or not. If you remember, I explained to you earlier on that there's 2 ways to reduce fractions. That the first method is the prime factorization method, and the second method is using the dividing, and that means just to dividing. And for you to know the prime factorization method, you need to have explained everything about that one. So don't let me stress anything about it again. So for some reason, I will not teach you the second method right now. You understand? I will not teach you the second method of reducing fraction right now, so that it won't be complex it will be complex for you. So what we are going to do right now, so I've explained the first one for you, which is the prime factorization method, and so later don't worry about this, and we'll explain this the dividing the second method for you. So what we are going to do now is that, so for now let us see how you can change from decimals to fractions. So this is the topic of the section, and I think you have learned a little bit about fractions and decimals. So let's see how we can change from decimal to fraction. So know this first. So the first thing you need to understand is that when you are reducing fractions, you understand, when you are reducing fraction, like if you are changing from decimal to fraction, and so when you are reducing such a fraction, you understand, because it's become easy. It's easy for you to reduce if you change fraction from decimal to, if you change from decimal to fraction. So it's easy for you to reduce the fraction, because no matter how large the denominator, you know the meaning of the denominator, that is the number at the bottom of a fraction, you understand. So it's always have to be multiples of 10, meaning that meaning that 2 goes in the number and 5 also goes in the numerator. That means you can easily divide it by 2 and 5. Don't worry, I will give you an explanation about that. I will give you an example on that and you understand it. But just keep all these things in mind. And then if the decimal ends in an even number, like if decimal end in an even number, for example now, So you can reduce the fraction. Now let's say we have decimal like 1.3, 1.5, 1.5 you can reduce it to lowest term, and we have let's say we have 1.3, that means you cannot reduce 1.3 no matter what the denominator is, you understand. So you can easily reduce them if the fraction, if the decimal, the number at the top is an even number or end in an even number like 2, 4, 6 or 8. So you can, otherwise you cannot reduce it. And the third thing is that if you have a number greater than 0, if you have a number greater than 0 before decimal, we have decimal point first and we have the whole part. You remember that one. So the number in the whole part, if the number is greater than 0, so if the number is greater than 0, you end up with a mixed number. I will give you an example, about that. So without wasting your time, let's jump right to the board once more and let's see how you can change from decimal to fraction. So the first decimal we want to change to fraction is 0.4. So you want to change the 0. 0.4 is decimal, and this is decimal point. You want to change this decimal number to fraction. So the first thing, whenever you see decimal number like this, is to first draw the fraction bar. You understand? So draw the fraction bar like this. So after you draw the fraction bar, so the next thing we are going to do after you draw the fraction bar is to write 1 at the denominator like this. You understand? And write the 0.4 in the numerator. So when you write it like this, you can now, because we are changing this to a fraction, you understand? So we move the decimal point here to this place. It's different from the one that we did the other time, that we are changing from fraction to decimal. So if you are changing from decimal to fraction, you move the decimal point to the left like this. You understand? Sorry, to the right. If you are changing from fraction, decimal to fraction, keep this in mind. If you are changing from decimal to fraction, you move the decimal point to the left. So until it reaches the last point here. So decimal point is here. After we move decimal point to the left here, to the right here, we had 1 0 here. So what we have right now is we have 0.4 point. And I tell you that whenever you see 4.0, you can easily change it to 4. Or it's the other way around, remember. What I told you that the other time is that when you have 4 like this, you can easily change 4 to 4.0. So we are not changing here. What only change here is that we are changing from 4.0 to 4. You understand? So we have 4 over 4.0. 0 is mean here. We have 4. We have 0. So what you can write now is that 4 over 10. But we are not done with the answer now. So remember what I explained to you, that first of all, when you are changing decimals to fraction, after you get the fraction like this, you have to reduce the fraction to the lowest term. You understand? In fact, if you are not told to do that, it's better to do that, because so that you'll be able to know. They will know that you understand. Whoever give you the question will know that you understand it better. So now going back to my explanation into how we reduce the fraction to lowest term using the prime factorization method. So we are going to find the prime factors of 4 now. So if you find the prime factor of 4, that means we have 2 times 2. You remember that one. And the prime factor of 10 will be 2 times 5. Now what is common in the numerator and numerator, for us to cross out, we cross out 2 and 2. So what remains now is 2 over 5. That means 0.5 to decimal, 0.5, which is decimal. If you convert it or you change it to the fraction, we are going to get 2 over 5. If you write 4 over 10 here is correct, but make sure for you to get the full answer, you have to reduce it to the lowest term and get 2 over 5. So 2 over 5 is the correct answer. So 2 over 5 is the correct answer. So let me explain this to you again so that you can easily understand, because after this one I'm going to give you an exercise and I will do the exercise for you. So we have a 0 point, we have 0.4. We want to change the decimal, we want to change to fraction. So we draw the fraction bar, we write 1 on the denominator here. So we write 0.4. We move decimal point to the left 1 times, because we are changing from decimal to fraction. You understand? So from decimal to fraction. So you move decimal point like this. You understand? So we move decimal point like this to the left, to the right, and we had 1 0 here. So what remains here is that 4.0 is still the same thing as 4. So we write 4 over 10, and we use the method that I explained to you. That means we reduce this fraction, this 4 over 10, to lowest term using the prime factorization method. So we find the prime factor of 4, and find the prime factor of 10. So we reduce the lowest term and get 2 over 5. So now that we have reduced 4 over 10 to the 0.4, we have changed it to decimal. So quickly do this exercise. So but before you do the exercise, keep this in mind that don't worry if you do not get the correct answer, and if you are having difficulties solving the questions, try to rewatch the example that I give to you. So don't try to watch my answer yet. So try to watch the example that we see now. That means how we change from 0.4 to decimal, and try to watch it and try to see how I did it, so that you'll be able to do it yourself. So and then we want to do all the exercise before checking the correct answer. So if you not do exercise and you go back to check the question, you won't know it. You will think you know it, but I bet you that you can never know how to change from decimal to fraction if you copy the answer without trying to do it yourself. You remember. So practice make perfect, and try to make it perfect. So the first exercise says that we are going to change the following decimals to fraction. The first one is 0.2. So change 0.2 decimal and change 0.8 to decimal, and also change 0.5 to decimal. So that notebook you have been working on, try and write just write change the following decimal to fraction and write number 1. So do number 1 before you write number 2, and do number 2 before you write number 3. And after that one, I will show you the answer. So pause the video now, and we'll jump right to the board, and I will give you the correction. So pause the video now. So here now we are doing the question. So the first one is that is 0.2. So if you want to change 0.2 to decimal, so if you want to do 0.2 to fraction, the first thing is that you draw the fraction bar, you write 1 here, and you write 0.2. You write 0.2. Sorry about that. So and you shift decimal point 1 to the left like this, you write 0 here. So that means what we have now is 2. What we have now is 2 over 10. And I told you that whenever you see a fraction like this, the fraction is not the lowest term. So try to reduce the fraction using the prime factorization method, because that's the first method I taught you. I have not teach you the second one. So what is the factor? 2 is a prime number. That means it has only only two numbers go there. We have the prime factors of 2 is 2 over 1 times 2, and the prime factor of 10, as we have been doing it before, is 2 times 5. So what is common in numerator and denominator here that we can cancel? 2 is common, and now we have 1 here, we have 1 here. So what remains now is 1 times 1 over 1 times 5. So that means the correct answer is 1 over 5. So 0.2, if you convert 0.2, change 0.2 to fraction, you are going to get 1 over 5. So that's the first answer. That's the answer for the first question. So the second question is 0.8. You understand? So it's 0.8. So as usual, you draw the fraction bar, you write 1 here, you write 0.8 like this. Because you are changing from decimal to fraction, you shift decimal point to this side 1 time. So and you add a 0 here, because that's only 1 time you change to do. Don't worry if it's not complex. Just follow along. So now we have 8, you understand, over 10. You can remember how this 8.0 means 8. You understand? So don't worry if you not have the same step as this. You can easily watch it, and you can. So now we have 8 over 10, and we want to reduce the fractions. We want to reduce 8 over 10 to the lowest term using the prime factorization method. We are going to find the prime factor of 8, which I've already did, and that will be 2 times 2 times 2, and the prime factors of 10 which will be 2 times 5. You understand? So what is common in the numerator and is common in the denominator? We have 2 here. So that what we have now is 2 times 2 over 5. So that will be 4 over 5. So 4 over 5 is our answer. That means 0.8 to fraction is 4 over 5. No, you can see that I don't use 1 here because I already know what I want to use. So that's why I just multiply it by 2 times 2 over 5. You understand? So you can still get the answer if you do it correctly. So the third question here, which is 0.5. So you want to change 0.5 to fraction. So the first thing is that you draw the fraction bracket as usual. You write 1 here, 0.5, as usual. So because we are changing from decimal to fraction, we shift decimal point to this side one time, we add 1 0, so that will be 5/10. So we want to reduce this fraction using the prime factorization method. We already know that 5 is a prime number. That means we are going to write 5 here, or 1 times 5. Let's do that one. Let's write 1 times 5 over, and the prime factor of 10 is 2 times 5. So now we see the common factor. The common factor is a common number here. That means 5 is common. So the answer will now be 1/2. So if you are asked to change 0.5 to fraction, that's 1/2. If you remember this one, the time we are changing from decimal to fraction to decimal, but don't worry yourself with this one. So 0.5, if you change it to decimal to fraction, sorry, that will be 1/2. I think that's the end of the fourth example and exercise. So another example here is to change from 0.48. You want to change it to fraction. So remember, z is equals to, so that will be 48. You have 0.0 here, you understand. So you shift decimal point 2 times here, 1 2, so it will reach here, because that's the, we shift the decimal point 2 times to reach the end of the number here. So because we shift decimal point 2 times, so we write 100 here. So what we have right here now is 48 over 100. That's nice, 48 over 100. So we are going to find the prime number of 8 now, of 48 now. So which will be 48. So if we check how many numbers can multiply together, will give you 48. So that will be 2 times 24. Yes. So 2 is a prime number, you circle it. 24 is a complex number. What can you multiply together? That will give you 24. So that will be 2 times 12. So 2 is a prime number. What can you multiply together? Will give you 12. That's 2 times 6. 2 is a prime number. You write 6 here. So this will be 2 times 3. Understand? 2 times 3. So here now, what we now have right now is that we have 2 times 2 times 2 times 2. So we have 1 2 3 4 times 5. Understand? So and the 100 one is let's do the 100 here. So we have the prime number of 100 now is, let's say we have 2 times 50 now. Understand? So and this will be 2 times 25. Is 25 a prime number? No, I don't think so. 25 prime number. What kind of class together will give you 25? There's nothing else. So and you know that 2 times 25 would be that's 5 times 5. You understand? So you can multiply 5 times 5 to get 25. So 2 is a prime number. 2 is a prime number. 5 also is a prime number. So there's no need to circle it. You already know that one. So let's just write it here. We have 2 times 2 times 2. Sorry. So 2 times 2 times 2 times 2 times 5 times 5. You understand? So what is common here is there's a lot of things that is common here. Let me change the pen to red here so that I'll be able to see this one clearly. So 2 is common here. Let's cancel out 2. 2 is common. Let's cancel out 2. No other 2. We have 5 here. Let's cancel out 5 here. So what remains here now is 2 times 2 over 5. So what we have now is 4 over 5. So if you have to change 0 over 0.4 to decimal, you understand? So the correct answer would be 4 over 5. Let me rub this up so that you'll be able to see this one clearly. But I've already did. You can rewind the video so that it doesn't disturb you that much with what I'm doing here. But I think you can grab what I explained. So it's not that difficult. And I've already explained to you how to find the prime number. So it should not be something that is difficult. So if you want to change 0.48 to the any fraction like this, any decimal like this, if you draw the fraction bar, you shift decimal point 2 times, because we can only shift it 2 times to reach the end of the number. So shift it 2 times, you write 20 at the numerator, and you find the prime factor of the numerator and denominator, and the answer will be this one. You cut out what is common there and you multiply this remaining one. So 0.48 now to decimal, sorry, to fraction will be 4.8. So that's that. Let's quickly do some examples. Let me give you some examples to do. So remember that if you not get it right, don't disturb yourself, and do all the exercise before checking the answers. So the second exercise will now be change the following to decimals. So 0.48 and 0.72. So do that one and make sure you pause the video. So before I show you the correct answer for it right now. I think I've did the 0.48 for you. So this is the 0.48. If you get the correct answer, so you might be wondering why I do this. I just want to know, maybe you actually do it yourself or you copy it from that place. So make sure you do it like this, and that's your answer. So let's quickly do the second one. Let's do the second one, which is 0.72. So we want to say 0.72 to decimal now, to fraction now. So we are going to write 1 here. So 72, 0.72. Shift decimal point to the side 2 times, like that. So we have 100 here. So we are now going to reduce 72 over 100 to decimal. So the prime factor of 72 now, let's quickly find it. So we have, what can I multiply together will give you 72. So that would be so if you check what you can multiply by another number that will give you 72. So that's 2 times 36. You understand? All these are just multiplication. You're supposed to upload that one. So we have 2 here is a prime number. What can I multiply with another number, that because 2 goes to 32, 36, you understand? So what can I multiply with 36 that will give you what can I multiply together will give you 36. Let's say 6 times 6 now. Let's stop using 2. So 6 times 6 is 36, you remember. So what can I multiply together will give you 2, that will give you 6. So that's 2 times 3, you understand? And here also we have 2 times 3. And then since we have 2 times 3 here, we now have 2 times 2. So that's the prime number. So we have the prime factor of 72 will now be 2 times 2 times 3. So we have 3 to the end. So times 2 times 3 times 3. And let's quickly copy the prime number of 100, the one we did before here, the one we did earlier on here. So it is 2 times 2 times 5 times 5. If you can see that one. So that's 2 times 2 times 5 times 5. So 2 times 2, 4 times 2, 8. 8 times 5 is 2 times 2, 4. 4 times 5, that's 20. 20 times 5, that's 500. Sorry, 100. So we cross out 2 here. We cross out another 2. There's nothing to cross out again. So we now have 2 times 3 times 3 over 5 times 5. So 2 times 3 is 6. 6 times 3 is 18. So we have 18 over 25, because 5 times 5 is 25. Now whenever you ask to change a decimal like 0.72 decimal, so to fraction, sorry, so the answer will be 18 over 25. You can't leave your answer here because this is not the lowest term. So now we see that 18 over 25 is the lowest term. So that's the answer, and that's it. I think that's the end of the second exercise. Show you how to the second method to reduce fraction to lowest term. Remember, the first method is that we use the prime factorization method. If we use the prime factor method, the second method is division. So let me show you this division now, the second method right now. So reducing fraction to the lowest term. So this is the diagram that I showed you earlier on, if you remember. So we have did the prime factor method. So here now really is now that you are going to know how to reduce fraction by division. So one thing you need to keep in mind here is that we must have to know you have to know what divisibility rules means, and it's not something that's complex, and I can even explain without teaching you divisibility rules. But the goal of you, my goal for you to learn divisibility rules, I think I'm saying something about that. But
my goal for you to learn divisibility rules is that actually so that you can work faster with whatever fraction you are changing to, you are reducing, so that you can be quick in actually knowing what number goes in a number, and so that you can easily divide it without ending up with a reminder or any other thing. So let's move on. So the meaning of divisibility rules means that how to know what number goes in another number without a remainder. You understand? So know if a number is divided. Know if a number divide another number. So 2 goes in a number. You understand? So we want to know now what. How do you know when you see a number like this? Let's say someone give you a number, or you see a number. How do you know that? How can you know without even doing any calculation that 2 can goes in the number without any remainder? So if the last digit of a number will be, sorry, if a last digit of a number is 0, 2, 4, 6 or 8, you understand? So if the last digit of a number, of any number you see, is 0, you understand, like 40 now, or 2, 4, 6 that end with 0, 2, 4, 6, that means the 2 can goes in the number without any remainder. So for example now, 2 goes in 22, 2 goes in 48, 2 goes in 102, and 2 goes in 346 without any remainder, and so on. So you don't need to know, you don't need to do the actual division to test this now. So what we are going to do, I'm going to we are going to move back to the actual topic of this video, of this part 6 video, which is changing decimal to fraction, and we are going to use this method to reduce the fraction we get after we change from decimal to fraction. So don't worry about it. Just know that whenever you see any number that ends with 0, 2, 4, 6, 8, know better that 2 can goes in the number. So how do you know what number 3 goes in? Now if the sum of the digits is divisible by 3, what is the meaning of this? What does it mean, the sum of digits? And I know you might not understand that one, so that's why I even want to give you a detailed example here. So let's move on. So keep in mind that 3 goes in 3, you understand? 3 goes in 3, that's 1, and 3 goes in 6, that's 2. So 3 goes in 9, and that's 3. So let me give you an example now. Now let's say we want to test if 3 goes in 285 without doing any division, without doing any calculation, too much calculation. We want to know, as we see 285 now, we want to know whether 3 goes in 285 or 3 does not goes in 2, or 3 does not goes in 285. Now the reason why you might be saying, why do you need to test whether 3 goes in a number? But for now you might not know how important it is, but don't worry, when I give you an example on how we change when we have to reduce fraction from a kind of fraction to when we want to reduce fraction, you will see how much is important for you to know by just looking at a number and try to guess if the 3 can goes in the number or not. So let's test now if 3 can goes in 285. First thing first, remember that 2 cannot goes in 285 because we not have 0 at the back of 285. That's 5 there. You understand? It's 5. It ends with 5. Sorry, it ends with 5 here. It's not 0. So if you have 0 here, let's say 280, now we know 2 goes in it without remainder. Now let's say if we have 0 here too, let's say at the back of this we have instead of 5 here, let's assume that we have 4. 2 goes in it, based on what I explained to you. And if you have 6 here too, 2 goes in it based on what I explained to you earlier on in how to know if 2 goes in a number. Now let's quickly move on to test if 3 goes in 285. Now I remember that in the first thing I said, when you want to know if 3 goes in a number, is that the sum of all the digits, I'm explaining this one, the sum of all the digits is divisible by 3. That means if you add all the digits together, if you add 2 plus 8, if you add 2 plus 8 plus 5, now 2 plus 8 plus 5 is 10. 2 plus 8 plus 5 is 2 plus 8 is 10, and we plus it with 5 so that it can be easy for you. And 10 plus 5 is 15. You understand? So this 15 also, now we put addition sign in the middle, and we had it, that's 6. Now if you add all the numbers together, you understand, like we had 2 plus 8 plus 5 now, and we get 6. Let's assume that you had any number together. You see a number, you want to test if 3 goes in the number, and if you add the number together like I did it here, I will still give you one more example, don't worry. If you add it together here and we get 3, or we get 6, or we get 9, knows that 3 can goes in the number without remainder. So since we get 6 here, that means 3 can goes in sorry, in 3 I made a mistake here, it's not 124. I probably did that one already. So you can know that 3 can goes in 285. Don't look at this one. 3 can goes in 285 without remainder. I know this might be funny, but don't worry. And 2 goes in 3 goes in 285 is 95. You understand? That means if you divide 3 by 285, you are going to get 95. So we have 3, we have 93 divided by 95. Sorry, 3 divided by 285 is 3. And let's test if 3 can goes in 889. So the first thing, as you usually do, is that you add 8 plus 8 plus 9. So 8 plus 8 is 16 plus 9. You understand? We get 25. And 2 plus 5 is 7. You understand? So since we get 7, we not get 3, we not get 6, we not get 9. And you can even see that I color this red. So that means 3 cannot goes in 285 without remainder. You understand? Without remainder, that's important. So because if you do not get 3, 6, 9 or 9, 3 do not go in it without remainder. And keep in mind that I said without a remainder, because if you divide 885 by 3, you are going to get 296.3. Now there is a remainder, and that point, that 1 over, I think 3 over 10, I think. So that 3 there, that point 3 there is a remainder. You understand? And if you check the first one we did there, there is nothing like decimal point here, and you can even familiarize yourself with decimal here. So let's check how we can know if a number can be divisible by 4. You understand? So 4 goes in the number if the last 2 digits is divisible by 4. Now what's the last 2 digits? What do you understand by that? Don't worry, don't disturb yourself too much. I will explain that one right now. But keep in mind that 4 goes in 4. You understand? So 4 goes in 4, that's 4. 4 goes in 8, that's 2. I probably write the multiplication table here, that 4 times 1, 4 times 2, 4 times 3, times 4, times 5, times 6, times 7. So note that 4 goes in all these numbers that I write here. You understand? 48, 44, and so on without remainder. So we are going to use that numbers as a benchmark now. Don't worry about what benchmark is. Just don't worry. Just look at this example, and when we change from decimal to fraction, you probably see a lot of this. And notice that I'm not giving you an exercise here, because this is not the main focus of this course. Don't worry, as I've said earlier on, you will see and you are going to master it. Don't worry. So how are you going to test if 4 goes in 124? So the first thing is that since 4 goes in 4, you know, I colored the red. That's the last 2 digits. You understand? That's the last 2 digits of 124. You understand? So since 4 can goes in the last, we can have 24 here, because we know that 4 can goes in 1 to 24. So that means if 4 can goes in the last 2 digits here, definitely 4 can goes in 124. And 124 divided by 4 is 31. I know you can see that one as that. 4 can goes in 124 without any reminder. And let's test if 4 can goes in 889. That's the number we used earlier on when we test if 3 can goes in 889. And you know that 3 cannot goes in 889, and 2 can also not goes in 889, because it's not end with 2, 4, 6, or even 8 or 0. Now once you test if 4 can goes in 889, I colored the last 2 digits here, because it said that if the last 2 digits is divisible by 4. You already see here that since the last 2 digits here is 89, and 4 cannot goes in 89, you understand, without remainder. So definitely if you divide 889 divided by 4, we are going to get 222.25. That means 4 cannot goes in 889 without a remainder. Now you have learned how to test, how to know if a number can be divisible by, if 2 can goes in the number without remainder, if 3 can goes in the number without remainder, and now we just learn if 4 can goes in the number without remainder. No, let's quickly check how to know if 5 can goes in a number without remainder. And I'll even combine 5 and 10 together, so that it will be easy for you. After this one, we are going to move back to what we have done before, which is we are changing from decimal to fraction. So how to know if 5 goes in the number? Any number that ends with 0 or 5, definitely 5 goes in the number without remainder. So, and keep in mind that 5 goes in 10, 15, 1725, because 1725 has 5 after it here as the last digit here. You understand? And 800, and that's 89,120 has 0 at the back here. That means 5 can goes, and you also know that 2 can goes in 89,120 without remainder, because it ends with the 0. You understand? So keep that in mind, and there are more numbers like that. That means anytime you see a number like 15, 10, 20, you probably know that 2 can go, 10, 5 can goes in the number without remainder. and then 10 can goes in the number if the last digit is 0. Now this 10 here, before I give you an example here, this 10 here, you know that 10 can goes here without remainder, and 10 in 10, that's 1, and 10 can goes in 9,120 because it also end with 0 here, you understand. So, and keep in mind that 10 can goes in 10, 2, 3, 2, 23,470 and 89,120 and so on. And I talk about the divisibility rules from 1 to, now you just learn divisibility rules, I mean how to know if 2 can goes in the number, if 3 can goes in any number without remainder, and if 4 can goes in any number without remainder, if 5 and 10 can goes in any number without remainder. Now there's an advanced primary section here. There's an advanced primary class. I will link to the video in the below description if it's ready, and if it's not ready, you probably might not find it there, but if it is ready, you are going to find it in the description of this video you are watching. But this is all you need to know to really break through in how to really reduce any fraction you see to the lowest term, you understand. So I've already teach you the first method, don't worry, you can use that one, and now I'm teaching you the second method, which is knowing how to reduce a fraction with divisibility rules. So let's quickly see how we can reduce the fraction and by using the division method. So this is an example here. Let's reduce 24 over 60 to the lowest term. The first step is that find the number that goes in 24 and 20 without remainder. So, and the second step is that you divide both the numerator and numerator by the number, and the third step is that you continue doing that until there is no number which can goes in numerator and numerator, and that's your final answer. Now I will jump right to the board right now, and I will show you how to reduce 24 over 60 to the lowest term. So let's go. Now probably so we are in front of the board. Let's say 24 over 60. As I show you now, so we want to reduce this fraction to the lowest term. So the first thing is that what number goes in 24 here and what number goes in 60. Let's first test for 2. So you can easily see that 2 can goes in 24. You understand. So we have 2 now. So the first number is that 2 can goes in 24 without remainder, and 2 can goes in 60 without remainder, because we have 4 here at the back here as the last digit here, and we have 0 here as the last digit. Remember that. And let's check if 3 can goes in 20. Luckily we can easily, since we know what number can goes in, we can easily divide it by, we can easily divide both the numerator and the denominator by it. But don't worry, let's check for 3. Let's check if 3 can go to 24 and if 3 can go to 60 without remainder. So if you want to test for 3 now, you can say 2 plus 4, and 2 plus 4 is 8. So because we not get 3, we not get 3, we not get 9, and we not get 6, you understand. That means 3 cannot go in 24 without remainder, but 3 can go to 60 because 6 plus 0 is 6. But that's the main point here. That means anytime you want to reduce a fraction like this to the lowest term, and you check for 3, you check for 2, whatever you check for, you just to make sure that whatever numbers you want to use to divide these two numbers, it has to be the same. You can't use 3 to divide the denominator here, and you can and use 24 to divide, and you use this is what I'm saying. You can't use 2 to divide 24 here because 2 can go to 24, and use 3 to divide 60 here. So that's not correct. I mean, this is what I'm saying. You can't say 2 divided by 3, and you can't say divided by 3. So this is not correct. You understand? This is wrong. So that's why we won't do that here. You understand? So since we know that 2 can go here, we can even also test for 4. If until we find a number that is not good here, that can go in 24 in the numerator and the denominator, you remember. So when we find a number that can go there, we can easily divide it by. But if you not find the number, just keep testing 5, 4. No matter how, you just have to know that you keep on testing 4, 2, 3, 6, and others. You understand? So though I not teach you 3 or 6, I not teach you 6, but don't worry about that. Just test for 1, 2, 3, 4, 5, and 10. You understand? That's enough for you. You understand? So now that we see that 2 can goes in 24 and 2 can goes in 60 without remainder, because how do we know that? Is that the last digit of 24 is 4 and last digit of 60 is 0. Now let's easily divide this by 4 now. Sorry, by 2. I'm not saying there's no another number that can divide that can goes in 24 and 60, but this is one that I get now, so it's the first one that I want to use. So now 24 over 60, 24 over 60, you now say divided by 2, and this one also divided by 2. Now how many 2 can you find in 24? You can just take it like this: 24 over 2. 2 here 1, 2 here 1, and 2 in 24 is 2. That means we get 12. You understand? Over how many 2 can you see in 60? Let me rub this. How many 2 can you see in 60? That's let's do 60 over 2. 2 here 1, 2 in 6, that's 3, and you just add the 0 at the back of it here. That would be 30. So how many 2s can you see 60? That's 30. I made a mistake here. This is 12. You understand? So now what can goes in? We cannot test that. What number can goes in 12 and goes in 30 at the same time without remainder? You understand? So we do as we do earlier on. Let's first test for 2, and I believe 2 can go here because we have 12 and we have 30 there. And let's also test for 3. So 1 plus 2 now. I've not write down that. So 1 plus 2 now. We want to test if 3 can goes in 12, and you know that you have to add this together. So we are testing for 3 now. Now what we want to test that if 3 can goes in 12, that's 1 plus 2, that's 3. Definitely 3 can goes in 12. Now let's check if 3 can goes in 30. So because we are saying 3 plus 0, definitely 3 can goes in 30 without remainder. You understand? So we now divide this by 2. Sorry, let's use 3 because 3 can goes in both. So we are now divide this by 3. Now divide this by 3. Now how many 3 can you see in 12? Definitely that's 4. You understand? Because 3 times 4 is 12. You understand? That means you can see 3 4 times in 12. That means this 4. And let me write it like this. So equals to, I write 4 here. Let me write 4 here. Then how many 3 can you see in 30? That's definitely because 3 times 10. You understand? 3 times 10 is 30. You understand? So now see, so definitely we can see 10 3s in 30. Now we still have another number here. What number can goes in 4 and 10 without remainder? Definitely 2 can goes and 3 cannot goes because just we don't have only one number here. But if you remember this now, if you remember what I said earlier on, that you want to change the number to the, we want to change, sorry, we are not changing any number to decimal here. So that means we are reducing fraction to lowest term. Sorry. So now what number can goes in 4 and what number can goes in 10? Definitely is 2. Let's say divided by 2, and this one also divided by 2. So our answer will now be 2 over 5. That means you can see all the work now. We are reducing the fraction to lowest term using this the divisibility method, the dividing method. You understand? So we check a number, what number can goes in 24, and at the same time that number must goes in the denominator in 60. We check that. Now earlier on we see that 2 can goes in 24 and 2 can go in 60, so we use 2. But we check 3 can go in 24 but 3 cannot go in 60. Sorry, 3 cannot goes in 24 because 4 5 6 3 can go in 24. I made a mistake there. So if you want to check if 3 can go in 24, that's 2 plus 4. I made a mistake there. So 3 can go in 24, sorry. So that's 2 plus 4, that's definitely 4 5 6, that's 6. I made a mistake there. So 3 can goes in 24 without remainder, and 3 can go in 60. So that means you can use 3 to divide this here. So 3 in 24, that's probably 4. Okay, that's 8. You understand? Oh yes, that's 8. 3 times 8 is 24. So and 3 can also goes in 60. But I made a mistake earlier on. So I'm sorry about that. So you can even see that no one is above mistakes. So if you made a mistake trying to work in math, is not something you should beat yourself up. You understand? So 24 divided by 20 by 2 we get 12, 60 divided by 2 we get 30. And now we see that 2 can goes in 12 and 30, but for the purpose of example here I use 3. So 3 divided by 4 by 12 we get 4, 3 divided by 30 we get this. And the overall answer, that means we reduce 24 over 6 to the lowest term and we get 5. That means there is no number that can goes in 2 and can goes in 5 without remainder. It's only 1. Since we get that one, there's no need for us to be using 1 to divide, because we are still going to get the answer. So that's it for how to reduce fraction in the lowest term using the dividing method. Now, since we are done with the changing reducing fraction to decimal, let's quickly jump to the board once time again, and let's continue changing from decimal to fraction. I bet you will love it. You understand? Now, since the video is long now, I won't take your time too much now. So all the fractions of decimals we have changed to fraction now. We are now going to see how we can change it to decimal to fraction again and reduce it to lowest term. Remember that we did 0.4, we changed 0.4 to decimal, and the answer we get is 4 over 10. Remember. Now we want to reduce 4 over 10 to lowest term without using the 2 plus 2 over 2 times 2 method. You understand? That's prime factor method. Without using this method, you understand? So this method is good. You can use it if you like it, but this is the most common one. So this one you can usually do this to do quick work, and you can even do it yourself. Don't worry about not using it. You can use it. Both the first method and the second method in reducing fraction is the same. But remember what I explained to you here. This one is just as it is. That means whenever you want to change a fraction to decimal, let me even explain it right, so that it serves as another example for you. So when you want to change a decimal to fraction, you draw a fraction bar like this. So you write 0.4, the decimal you write on top, and you write 1 here. So because you are changing from decimal to fraction, you shift the decimal point to the left, to the right like this one time, and you write 0 here. So the number we get right now is 4 over 10. I bet you can easily know the reason why I removed decimal point, because if we have 4.0 now, and 4.0 is also equals to 4. Remember that I explained that to you. Now, because we are not changing from decimal to decimal, you understand, that would be just doing so, because I see a lot of people make mistake and change from 0.4. So whenever they see 4.0 like this, they just change it to decimal like this. They just do 0.4 again. So don't make that mistake. This is not correct. You understand? Let me use red thing there to write that one. So this is not correct. You understand? Because you are changing from decimal to decimal again. So it's not correct. So don't do that one. What you're supposed to do now is that after you change decimal to fraction, and you see that the fraction is not in the lowest term. You understand? So you can just change it. You can just reduce. You have already get the answer here. You understand? But this is not a professional answer. So you have to reduce it to the lowest term, which is finding what number can goes in 4 and goes in 10 at the same time without remainder. You understand? So if we test for 2 now, we know 2 can goes in 4 and 10 without remainder, and we know 3 cannot goes in 4 and 10 without remainder, because 3 cannot goes in 4 and 3 cannot goes in 10. You understand? Because if you add 1 plus 0, that's 1. You understand? We not get 3, we not get, and that's all. So let's use 3 for now. So divided by 2, let's use 2. Let me rub this. Okay, so divided by 2, and this one also divided by 2. So that will be equals to, how many 4 can you say in 2? If you count 1, 2, 3, 4. I'm counting like this so that you probably see do 1, you understand, 2. Then you can see 2, the answer is 2. And how many 10 can we say in how many 2 can we say in 10? So you can easily cancel like that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, that's 1. I'm falling because I'm counting. That's 2. 1, 2, 3, 4, 5. So the answer is 5. That means we get 2 over 5. So this is our answer. So remember the mistake I mentioned earlier on, that you should not, because if you see 4 over 10, if your answer is 4 over 10, sorry, if your answer is 4 over 10, like we get here earlier on, like we get here before, so don't try and change it to 0.4. You understand? Because you know how to change fraction to decimal. The question is that you have to change 0.4 to fraction. This is a fraction. Now you can see we have a fraction bar. You remember that one. We have the numerator we have the numerator here and we have the denominator. You understand? So we are not asked to change decimal to decimal. You understand? So keep that in mind. So the correct answer is 2 over 5. So if you are asked to change the 4 over 0.4 to decimal now, to fraction now, sorry, that means the answer will be 2 over 5. There's no need for you to draw the line here. I'm just drawing the line here so that you're able to see it. So don't make mistake with that. So this just is, and that's the correct answer. So whenever you are asked to change a fraction to decimal, if a decimal to fraction, after you change it to like this, that you change it and you get 10 as the denominator, knows that 2 can goes in 10, so just divide the both side, the denominator and numerator by 10. Now there's one more example here that I want to show you, and I even want to do every other fraction that we have converted to decimal. I'll quickly use it as an example for you. So let's say we want to convert 0.48 to decimal to fraction now. So we already know that the answer will be 48 over 100. I don't want to be wasting our time on that. So what number can goes in 48 and 100 without remainder? 4 can goes and 5 cannot goes in 48, but 4 can goes in both sides. You understand? Don't worry how I get that one. You can easily test it. So 4 can goes here and 4 can goes here. You understand? So how many 4 can you find in 48? That's 12. How many 4 can you see in 100? That's 25. So what number can goes in 25 and 12 without remainder? So 1 plus 2, I'm testing for 3 here. We have 3. That means 3 can goes in 12. But can 3 goes in 25? Let's say 5 plus 2, that's 7. That means 3 cannot goes. 4 cannot goes, nothing can go. So 0.5, 0.48 to fraction is 12 over 72. You understand? Is 12 over 72. Now there's one thing that I want to explain here. We are still in changing fraction to decimal, and this one more example here. So let's assume that you are asked to change 4.1 now to fraction. You understand? 4.1 to fraction. So you draw the fraction bar, you write 4.1 here and you write 1 under it here. You shift decimal point 1 time to this side now. So that's, you write 0 here. So we are now having 41 over 10. Now there's nothing can goes in 41 and nothing can goes in that can also goes in 40. So 41 is a prime number. You can go back and cross check that video that I explain prime number to you. So 41 is a prime. That means there's no number can goes in 41 except 1 and 41. And since we can't divide this one by 1 by 41, and we can also, and we can't divide this one by 5. You understand? So this is wrong. You understand? So you can't do that. So the best way to go about this is that whenever you see a fraction like this, this is an improper fraction. If you can remember, let me use this red color to explain to you. Because the bigger number is at the numerator now. This is big. You understand? And the smaller number is at the denominator there. You see 10. You understand? So when we have a number like this, that is an improper fraction. That means not proper. You understand? So when you see an improper, when you are working with when you are changing from decimal to fraction, you understand, and you get an improper fraction like this, you are going to change it to a mixed number. So keep that in mind. If you are changing from decimal to fraction and you leave your answer like this, it's not a professional answer. You understand? And you want to become a professional mathematician, I can see that in you. So how many 10 can you find in 40 now? That in 41 now, that's 4. You understand? You can check 4 times 4, that's 0, that's 40. That means remain 1. Even that one, that's 1 over 10. So this is our answer. So 4.1 to fraction now is 4 number 1 over 10. You understand? So I'll give you an exercise now. So practice makes perfect. Don't worry if you not get the correct answer, but just don't and try to watch my example. Try to watch the example and make sure you check I do the exercise yourself before checking my correction. So change the decimal to fraction. Change 8.4 to fraction. So pause the video right now and do the exercise. So don't worry if this video is too long. You know you can take more time. Those who want just to pause the video and rewind and make sure you understand it. My goal for you is not to watch this video in just a day. You understand? It's not for you to watch in a day. You can watch it 2 days, 3 days, no matter how. But just don't worry. Let's continue. I want to give you 2 more examples here. If it's enough, 2 more examples. So the first example is to change to change 27.8, you understand. So 27.8 to fraction, you understand. So the first thing, draw the fraction bar, write 27.8 here. So this 27.8, and then so shift decimal point one time to the left here, and you write 0 here. So what we get right now is 278 over 10. You know that 10 can goes 2 can goes in 278, and 2 can goes in 27 in 20 without remainder. So divide by 2 and divide by 2. So if you divide 278 by 2, you can easily check it. How many 2 can you find in 12 in 2 in 27? So 2 times, let's say, let me do this. So let's choose the number. Let's choose like 15 now. So 2 times 15. So 2 times 5, that's 10. 2 times 1, that's 2. We have 20 here. So 2 times 5, that's 10, plus 1, that's okay. Let's choose 16. Okay, let's choose 12. Let's choose 12. Sorry, let's choose 15. Let's choose 16 here. So sorry about that. So let's choose 16 here. 16 times 2. So 2 times 6 is 8, and 2 times 1 is 2. So we have 20. Definitely we are going to use 2. You understand? So that would be I think I made a mistake there. So you want to check how many 2 can I find in 27, right? Okay, and we check 2 times 5, that's 10. We keep 1. 2 times 6, that's 12. I made a mistake here. I can see 2 times 6, that's 12. You understand? So we keep 1. 2 times 1, that's 1, plus 2, that's 32. Definitely we can say who made a mistake here. So you might have seen it, but just I'm really sorry about that. So 2 times 5 is 10, right? So you write 0, you keep 1. 2 times 1 is what? Is 2, plus 1, that's 3. Definitely we are going to reduce this. So let's say 13 times 2. Yes, 2 times 3 is 6, and 2 times 1 is 2. Definitely we are going to use 2 here. That means we can see, okay, we are going to use 13. You understand? So we can see 13. How many 2 can you see in 27? That's 13. You understand? Remainder 1. You understand? So 2 in 18 now, that's 9. 2 in 18, that's 9. You understand? So we now have 139 over 5. You already know how many 2 can find in 5. You can find in 10. You understand? So when you have a number like this, that nothing can goes in 120 at the same time can goes, because 5 cannot goes in 120. That means you see these are an improper fraction, because the top number here 138 is bigger than the bottom number here. That means when you see an improper fraction like this, when you are changing from, if you are changing from decimal to fraction, and you end up with an improper fraction like this, you have to change it to a mixed fraction. So what you can do now, how many 5 can you find in 137, 139? Just let's check how many. Let's check if we can see 27 5 in 1. So 5 times 7 is 50. Sorry, that's 35. 2 times 5 is 10, plus 2 times 5 times 7 is 35, right? That we keep 3. 5 times 2 is 10, plus 3, that's 13. So okay, that's 13. That means we have 27 whole number. You understand? 27 whole number. What remain here? That's 4. 4 over 5. 4 over 5. So let me clear all this and quickly re-explain to you again. So so if you want to change a fraction to decimal like this, you remember this pattern, but the only part here that's hard is just this. So just see how many 5 you can find in this. You can calculate it yourself and get 27, and the answer will be 27 over 4 over 5, and this is the correct answer. So this is also correct, but it's not a professional. That means you can't leave an answer like this. You have to change it to an improper fraction like this. As usual, don't copy the answer, and so do this exercise for me. So change 31.2 to decimal and change 12.16 to decimal. So pause the video right now. As example here, we want to change 7.735 to decimal. You understand? So you draw a fraction by like this 7, not 1. So you write 7.735, this 7 and this 7. So you write 1 here. You shift the decimal point 1 times like this, you write 0. Shift the second time, you write 0, and you shift it the third time, so you write 0. What we have right here now is 7.735 over 100. You understand? Over 1000. Sorry, over 1000. Now the next thing is that what can goes in because what you know that this number end in 5 and this also end is definitely 5 can goes in both number. So if you divide the both number by 5, you understand, your answer would be divide this one by 5. You understand? If you divide this by 5 and you divide this by 5, so the answer for this one would be 1547, and the answer for this one would be 200. You understand? Would be 200. Now since nothing can go, just change to fraction, and that's the answer will be to mix fraction because the denominator here is bigger, and just changes to 7 number 147 over 200. So don't worry about this, it is not complex. You just need to keep two things in mind. You understand? The first thing is that we shift decimal point 3 times here, and second thing is that the denominator is bigger, so we change it to a mixed fraction here. So that's the main thing for you to just that you just need to keep in mind. You understand? So this one, so that's just the two main things you have to keep in mind. You understand? So the first thing is that we shift decimal point 3 times here until it reaches back here, and here we change this one, this 17547 to a mixed fraction like this. Sorry, to a mixed number or a mixed fraction like this. So I think so. Let's quickly do some exercise. Don't copy my answer and do the exercise here before you do. So change 5.88 and 4.44 to decimal. So and I think that's it. Pause the video and make sure you do the exercise. And now that I see that I not give you the correction for is that 31.2? Okay, 31.2. You understand? So you just draw the fraction by like this, and you change decimal point two times, just 2 times. 31.2 like this over 10. You change decimal point 1 times to this side. So these are an improper fraction. You have changed to a mixed fraction. Check how many 10 can use in 312. So definitely that would be 31. Let's check it. 31 times 10. So just put 0 here. That's 310. Definitely the answer is 31 whole number. Sorry for the way I write 31 there. So that would be 31 whole number 2 over 10. And we can even reduce this one further. That would be 31 whole number 1 over 5. Understand? So that would be 31 whole number 1 over 5. So that's 31 whole number 1 over 5. So that's the correction for the first one. And the second one, which is 12.16, 12.16. Sorry, it's not 12.16, 12.16. Draw the fraction by like this, and you write 100 here. No, I'll be fast with this one. I'll be fast with this. So this is 12.16. You understand? So what can go here and here without remainder? 2 can goes. So you can divide this one with 2 and 2. So divide by 2 now, and this one also divide by 2. So how many 2 can you see in 12, 26, 12, 16? That's 1216. That means we can find in 12 we can see 6, and in 6 we can see that's 8. You understand? That's 8 over 50. 68 over 50, sorry. So we can even divide 68 by 2 and 50 by 2. You understand? So that's in 6 we are going to find 3 there. 2 times 3 is 6, and this is 4. So we can see 34 over 25. So what can goes in these two number without remainder? 2 cannot goes here, 5 cannot goes. So let's now move the changes to the mixed fraction, because the top number here is bigger. So how many 25 can you say in 34? That's one whole number. How did I know that one number is that? 24 2 times is 50. You understand? You can remember that one. So let me clear this. So now we have one whole number. What remains now? We now subtract 34. By subtract 34 from 25 now. So subtraction sign here. So borrow 1 from this one. This will be 2, and this will be 14. Understand? So how many 5 can I find in 14? That's if I remember right, that's 9. Understand? So we have remainder 9. So that's 9 over 25. So the answer is one whole number, 9 over 25. That's the answer. So that's the correct answer for this one. And the second exercise that I gave to you, which is I think if I remember right, that's 4.44. That's 4.444. So you draw the fraction by like this. You write 1000 there. That's 1000. You understand? And this is 4 4 4 4. That's 4 4s there. Understand? So 2 can goes in this without remainder, but let me use dividing by 2 2 2. So let's if you divide this by 2, you understand, I will divide this one also by 2. So in numerator we are going to get 2 2 2 2 and 2 here, and the denominator we are going to get 500. You understand? 2 can goes again, divided by 2, and this one divided by 2. So here we are going to get 1. This equal to, so this 1 1 1 1 over 25. Is that 25? Yes, over how many 5 can that's 25 over 250. There's 250 or 250. Nothing can go here, nothing can go here without remainder. So we have to change it to a mixed number. So how many 250 you can find? The 1101. So definitely if you do it right, that's 4. You understand? And 4 times 250 is 1000. That means the answer now is the answer that remains is 111 over 250. So that's the correct answer. That's the correct answer for this. So I think okay, it remains one more exercise that I give to you that you want the correction. So here now we are changing 5 points. I think okay, it's 5.88 to decimal, sorry, to fraction. You understand? So you draw the fraction by like this, and because you are going to change decimal point 2 times, and this will be 588. You understand? So 8 can go 10 can 8 2 can goes in both sides. So 2 in 5, so divided by 2, and this one also, divided by 2. You understand? So how many 2 can I find in 5? That's 2. So in 18 we have 9. So and in 8 we have 4. So how many 2 can I find? 284 480 588 now, that's 294. You understand? So in 100 we have 50. So 2 cannot go so good. We can easily divide this one by 2, and we can divide this one also by 2. So 2 in 298, 2 in 20 in 2 that's 1. In 9 we have 2 times 8, that's 4, remainder 1. And in 14 we have 7. In 14 here we have 7. If I don't know that kind of division, I might teach this in the advanced class, but don't worry, you can easily just divide 2 by 2 for 94 here. So in 250, in 50 we have 25. So now there's nothing can goes, and we have the bigger number here as the denominator. That means we are going to change it to a mixed number. Now how many 25 can you find in 148? That's definitely, that's 5. You understand? So and 25 times 5 now. So 5 times 5, that's 25. Write 5, keep 2. 2 times 5, that's 10 plus 1. That's 2 times 5, that's 10 plus 1 plus 2. That's 12. That's 125. So we have 125. You understand? So if you now subtract 147 minus 125, so we are going to get 20. Is that not 22? Okay, 22. So the answer will now be 22 over 25. So that's the correction. So 5.88 to decimal now, to fraction now is 5 whole number 27 over 25. I think no, that can be, sorry, I made a mistake. It's 22 over 25. So maybe I should write that one. So that's 22 over 25. So change 5.88 to decimal, sorry, to fraction. The answer is 5 whole number 22 over 25. So that's it for this video. I know this is a long video, and you have been learning how to convert decimals to fractions. The only hardest part is that it's not even difficult, but you have to know that when the numerator is bigger than numerator, you change it to mixed number, and we can quickly go back. I don't expect you to watch this video in just a day or a whole day or in just an hour. Just go back. You are free learning here. Just go back, rewind the video, watch the video, and make sure you understand any concept or the concept before you move on to the next part of this video. So feel free to watch, and if you have any difficulties working with any question in this video, feel free to comment in the below section, and I will reply to it and even explain to you in a better way. Goodbye for now. So watch the next video and make sure you move on to the course.